8.6 logarithmic differentiation. Let's go through this first example. So basically, if we have y equals x to the x, we want to find y prime. I know I say this every class, but what I want you to watch for is the pattern of behavior. We're literally doing the same thing each and every question, each and every example, but the function changes. So if you can view it that way, it's going to make it easier for you to work with this. So if we want to differentiate this, my first step is I'm going to take the ln of both sides. So this would be ln of x to the x. The reason I thought to do that is because I noticed that I have x to the power of x up here. So technically I haven't changed anything, right? Because an equation is like a scale. If I do this to both sides, no big deal because I'm keeping them balanced. And then we want to take the derivative of both sides. So if I take the derivative of ln y, what is the derivative of ln y? 1 over y, and then whenever we take the derivative of y, what do we need to attach to it? We need to put a y prime there. If this stuff ever seems overwhelming or there's a lot of stuff, just do it step by step. So if we just focus on the left side, we know that this is how we would go about it. And then do you remember that, I don't know, maybe the first day we did this stuff, we reviewed and looked at how I could rewrite this, like pull down that exponent and call it x ln x. Sounds familiar? So I'm actually going to write it here. Do you see it's like, I don't need to put the dot there, but I want to make it clear that it's just saying x times ln x. So if we want to take the derivative of this, which rule do I need to consider or work with? Yeah, so do you see, I don't need to write this, but I'm going to do it so it's super clear where we got this from. Do you see that I would have 1 times ln x because the derivative of x is just 1? And then I would have plus the derivative of, well, I could just leave the x, but what's the derivative of ln x here? Yeah, it's just times 1 over x. So I guess what I want you to get out of this is the approach. And clearly we can see if we're looking at this, they're simply going to cancel. So really, I just have y prime equals, do you see if I'm trying to take the derivative, I want to get the y prime by itself. So it's going to be this y, I'm going to multiply on both sides, and then it's going to be times ln x plus 1. So far so good? And then that y was equal to this x to the power of x. So my last step is I want to plug that back into here so that I'm only dealing with x's. And I can say y prime equals, and when I plug that in, it would be x to the x times ln x plus 1. We could distribute that if we want to. If you leave it like this, that's fine. I'm not going to worry too much about that stuff, but what I want is for you to, again, have those skills of being able to take the derivative when you see something like this. So far, so good? Okay. On to the next one. You know what I used to do? I used to start with this one, and then I looked at it today and thought, why am I starting with this? This looks like a nightmare, but it's not. Now that we went through the other one, I want you to try to view this the same way and see if you can simplify this. So what we're trying to find is y prime. And our first step in doing that is just like last time. Angela, can you do me a favor? Can you close the door, please? Thank you. And we're going to take the ln of both sides. So I'm going to put a big, huge set of brackets there. All over e to the x. Like that. See that, like, yeah, there's more stuff going on here, but do you see we're doing exactly the same thing as in the last one? And when we go to do that, again, the right side looks like a nightmare, but when we look at the left side here, this is just like what we just finished doing, right? What is the derivative of this ln y? Yeah, it's just going to be 1 over y times y prime equals, and then we want to try to clean things up or make it easier to work with. So when I look at all of this stuff that's happening here, I can sort of think backwards and use my log rules. Remember the very first day we went through some of the log rules and reviewed them? So let's sort of use this as a chance to practice some of those as well. So do you see that I can separate this by saying ln of x cubed plus, I'm going to try to color code these. If we look at this part, we could say plus ln of x squared plus x plus 1 all to the 4. And then we could say minus ln of e to the x. There's the x cubed, where that came from. Do we see where that's all coming from? And it's bringing hopefully some clarity to stuff that potentially could be confusing. So we're basically breaking it apart to try to make it easier to work with. Do you see that I could rewrite this by saying 3 ln x? I'm just being lazy and doing it all in that step. So again, just pulling that forward like we've done in the past to make it a little bit easier to work with. And we could do the same thing here. I could pull that 4 in front to say 4 ln of all this stuff. And then actually, let's just make this way easier. If I were to pull that down, I'd have x ln e. What is ln e? It's just 1. Does everybody see the reason for that? What is ln the same thing as? Log base. So it's like log base e of e. So that whole thing would wipe out, and this would actually just leave us with an x. Do we see the reason for that? Maybe I shouldn't have done that because some of you look like, what is she doing? So we would have had this, right? Because we had ln e to the x. And then I took that little x up top and I swung it in front here. And then I look at it and think, well, x ln e, that's just a 1. That's how I'm left with only an x. Good? So far, so good? Actually, I'm a little bit messed up in this. I was supposed to be taking the derivative of this because that's what we did on the left. So can we do that now? Let's do that now. What is the derivative here when we're looking at this first one? Right here. I feel like that's not working. Let's do this. Like that. So what's the derivative when working with this? What do we end up with? 3 over x. Everybody good with that? 3 over x. How about if we're taking the derivative of this whole thing? There's a bit more stuff going on here. What would we have happening there? I'm going to try to, okay, can I do this for a sec? We're going to live in denial. I've been teaching the grade 9s how to live in denial. For a little bit, we're going to pretend the rest of it doesn't exist. We're just going to focus on this little blue thing in the middle. Is everybody okay with this? Okay, this is the secret to life. Live in denial, like just for a little bit, and then you have to bring back the reality when you're ready for it. Do you see that if I just took all of this stuff inside and called it m, what would the derivative be? 4 over m, but it's not m, it's all this stuff, right? So it's actually 4 over all this stuff, x squared plus x plus 1. Do you see where that thought process is coming from? Like we normally do 1 over x, but it's not x, or it's not m, it's all this stuff, right? But what do we need to think of or consider when we're taking the derivative of something that has all this stuff inside, Malcolm? The chain rule. So what do I need to also multiply this by? Thank you. So the derivative of whatever is on the inside. So the derivative of whatever is on the inside would be 2x plus 1. Are we all good with that? See what I mean? It's like organizational stuff. I'm not so sure it's like difficulty like in terms of the level of math. I think it's organization. So, oh, this is just me being lazy, but let's get rid of that. And let's move this up. Good? God, I love this thing. It allows me to be lazy. Okay, remember how we were living in denial? We have to take the derivative of this last part, which is 1, right? Minus 1. Everybody okay with that so far? So what potentially was a nightmare, just lots of stuff going on, we can take a step-by-step approach and then hopefully you'll find it's not too bad. I'm not just saying this. So last block, this wasn't working. I had to use the whiteboard, my worst nightmare. And it made me appreciate the colors make a big difference in making it easier to understand. So if that works for you with your notes, make sure you do that as well. What do I do next? Isolate the y prime. So you know how over here we had times 1 over y? Do you see I could just take the whole thing and multiply by y? And that isolates my y prime. And then, oh, you're going to like this. Guess what we get to do? Well, this is what y is all equal to. We're going to take that and plug it into there. Isn't that fun? So, we have y prime equals, it was x cubed times x squared plus x plus 1 all over e to the x times, Malcolm? At the bottom? Oh, thank you, here, right? Thank you. Holy, you're quick. I didn't even catch that. Plus 4 times 2x plus 1. We could combine those if we want to, but it doesn't really matter. And this is another example of one of those scenarios where it's a nightmare to mark. So let me tell you what I would do with this. It's also a nightmare to work with this because I can anticipate all the questions of what form do you want this in, how much do we have to simplify, So when in doubt, simplify as much as you can. That's the best thing to do. But I think for the sake of everyone's sanity right now, I would give you when x equals 1 or when x equals 2 or something like that to minimize the rigidity of it, to allow you some flexibility to be able to basically do it however you like. Good?
That was easy.
No, it was not bad, right? The living in denial approach is working. Good stuff. Can we handle one last example that combines trig and exponents? Trig and logarithms. This is like all of life. This is like the answer to life. Yeah. You'll feel so good after. So we want to find y prime again. Ln y equals, do you see that I could take ln y of cos x to the power of sine x, but then I can pull down that sine x? So I felt the need to explain that because it's going to look weird. Sine x and then ln of all of this of cos x. And I feel the need to put it in brackets, although I don't know that they're really necessary, but I feel like it just looks better. Everybody with me so far? So it's like we took that exponent of sine x and we pulled it to the front, just like we've been doing with just the little number, but now there happens to be a bit more stuff going on. This is a lot all in one question that doesn't look like it's that much, but it kind of is. It's a mixing of a few different concepts. See why we're starting to live in denial? Are we good with this so far? Good? Okay, so then the derivative of this we've done many times now. We know it's 1 over y times y prime. So we're good with that. And then what do I need to consider? What's going to happen when I do the derivative of all of this right side? Do you see that? I don't need to put that there, but do you see they're being multiplied? So when I go to take the derivative of all of this, we would get cos x ln cos x plus 1 over cos x times negative sine x times sine x. What did I just do? Or like, what is that? Do you see it's the product rule? But within the product rule, when we go to take the derivative, what's the derivative of this would be 1 over cos x. Do we get that? And then what do we need to consider when doing that? Malcolm? Chain rule, right? So again, then we need to make sure that we're also taking the derivative of what's, well, I feel like that arrow didn't help. Like basically take the derivative of that. Good? And then times the sine x that was already there. So again, you see what I'm saying with the keeping track of things? Wait, am I doing, is this right? That sine x is that sine x? Good? So we understand where it's coming from. Again, use what you need to use to help you if it's like using colors, underlining it, whatever, but I really think I can see the potential for like leaving something off, forgetting something. And I think one of the ways to avoid that is to have good organization so you don't forget something. And then the rest of this is basically trying to simplify things or make it a bit easier to work with. So we have, oh, that's the wrong color. We have our y prime equals, we want to take this and move it to the other side. So we can say times y. And then when we go to clean this up, we have cos x ln cos x. Nothing much to do there, but here we have quite a bit we can do. When we put this all together, we have minus sine squared x over cos x, like that. So far, so good? Well, there's a couple of things happening here. Maybe we'll leave the y till the end. So we're going to deal with this eventually. But for now, do you see that to simplify this, I could multiply by cos x over cos x, meaning there and there. So I get a common denominator. Does that make sense? So I'm not actually changing anything. I'm just multiplying by 1. So I can do that as long as I distribute it to both of these. And in doing that, I still have this y. So y prime equals this y. And then I would have my Is that going to help us? Yeah. Yeah, we could. We could have tan x times secant x. Here, you mean? Let's say this. You know how I said that I'll allow you flexibility? So again, I'm okay if you leave it like this, except for let's plug the y back in. So to show you what I mean is taking this and plugging it back into here. I guess not that part, but this part. So once you've done that, I could say when x equals 1 or when x equals pi or whatever we want to make it equal to, but we can leave this as y prime equals, what was my y? Cos x to the sine x, cos x to the power of sine x. And then here, whoops, we have our cos x ln cos x minus sine squared x over cos x. So yeah, do you see here, we could say this is sine x times sine x so that it would give us sine x over cos x, which is tan x. And that would be fine. You could have tan x, times sine x, not secant x. Or you can leave it like this. Like, this would be okay. I would be fine with this. If you want to change it to another form, that would also be okay. Just remember to plug this cos x sine x back in. And I'm going to assign page 395, numbers 1 to 3 all.